So this is what we were doing. We were doing the third case where we are dealing with active electrodes. Okay, active electrodes, or we are dealing with active anodes, right? So let's see. Till now we have focused on the electrolytes, whether the electrolytes are molten or they are the aqueous electrolytes. So aqueous electrolytes can be your either dilute or they can be your concentrated. So our focus was basically on the electrolytes and we were ignoring the electrodes. But now we will be focusing today, we will be focusing on the type of electrodes. There are two type of electrodes basically. We have inert electrodes and we have an active electrodes. Inert electrodes are those electrodes which do not interfere with the process, interfere with the process. They do not have any say during the process. Okay, during the process of electrolysis. And the example of the inert electrodes are your graphite and platinum. That's graphite, which you can represent by a symbol carbon, and the platinum. These are the two examples of inert electrodes. Now coming to an active electrodes. The active electrodes, as their opposite of the inert electrodes, now these electrodes, they are unlike your inert electrodes. They interfere in the process of electrolysis, right? In the process of electrolysis. Now, whichever ions is supposed to, we are aware, okay, there are certain ions, like always the cations, they move towards the cathode during the process, right? And at the cathode, they gain the electrons. They gain the electrons. And similarly, anions, they move toward the anode, and what they do, they lose electrons. So the loss of electron, whatever the loss of electron take place at the anode, those electrons are moved to the cathode, and there the cations, they grab those electrons. So this is how the process take place. Okay, so that is the reason at the anode oxidation take place and at the cathode reduction take place. And over here, my electrodes are basically inert because their work is just the conduction of current, and that is what they're doing. But when you talk about the active electrodes, so active electrodes are conducting current, definitely. One of their role is to conduct the current. But apart from the conduction of current or electricity, they are also interfering with the process, Now, how are they interfering with the process? That means this is the process which is taking place. The cations, they are gaining electrons at the cathode, and anions are, this is actually what is happening in the electrolysis. So somehow they're disturbing this process. They are interfering and they're disturbing this process, right? So how they're doing it, let's do step by step. Okay, now their role is conduction and they're interfering with the process. Now active, we only have to do the cases of active anode, right? So active anode, those electrodes are said to be active anode if supposing whatever the material they are made up of. Let's say I have an anode or I have an electrode which is attached, because it's an anode, so it will be attached to anions are coming to it, so it is going to be attached to the positive terminal of the battery. Okay, so this is going to be my anode, and the other electrode is attached to the negative terminal, so that's going to act as a cathode. This is negative, so this is going to be act as the cathode. This is going to work as an active if it is made up of whatever the material it is made up of, whatever the metal it is made up of, apart from the platinum and graphite, whatever the metal it is made up of, if let's suppose it is made up of copper. If it is made up of copper, तो ये कॉपर मेटल का जो एनोड है वो अपने ही सॉल्ट सॉल्यूशन में डिप्ड हो. So that means copper anode or copper electrode, if it is attached to the positive terminal, so it's going to act as anode. It need to, in order to act as an active anode, it need to be dipped in its own salt solution. So that salt solution can be copper sulfate aqueous, or it can be copper nitrate aqueous, or it can be any other copper salt. So if that anode, the metal anode, if it is dipped in its own salt solution, then you call it an active anode. We have other examples also. Now, for example, if I want to have a nickel as an active. So what I'll do in the case of a nickel, I will have the nickel. If I don't want copper, if I want this to be made of nickel, so I need to have a salt solution of nickel, salt solution. That can be nickel nitrate or whatever, but it need to be a soluble salt, right? So if I want to make an anode, active anode, then only scenario, only condition I have to look into, that I have to make it dip whatever the material is it made up of. I dip it into sulfuric acid. Is it going to act if I dip it into dilute sulfuric acid? Will it act as? No. So the condition is, if my anode, whatever the metal it is made up of, it is dipped in, if it is dipped in its own soluble salt solution, then this anode will be treated as an active anode. Okay? Whatever the metal is made up of, that anode is made up of, it is dipped in own salt solution then. So if I want to make this as an active copper anode, then I have to I have to dip it in its own salt solution. So I can have copper chloride soluble, or I can have copper sulfate aqueous solution, or I can have copper nitrate solution. Any soluble salt of copper should be there. Is it clear? If I'll have any acting as an anode, so I'm taking copper sulfate over here. Okay. Now what happens when the active electrode is being formed? So it's the other electrode, no matter if the other electrode is also made up of copper, it's okay. But we are not dealing with the cathode as an active. So cathode will be, if even if it is made up of copper, it will it will still be acting as an inert. We are just taking the cases of, in our syllabus, we are just dealing with an active, right? So even if the cathode is made up of copper, it's going to, you're dealing with the active anode at the active as an anode. ठीक है? अब होता क्या है? Now अब इससे तो हो गया, एक कॉपर एक्टिव एनोड बन गया, अब होगा क्या? अब बेसिकली अगर हम एक नॉर्मल सिनेरियो देखें, अगर हमारे पास नॉर्मल सिनेरियो है, if we have, let's suppose we have a graphite electrodes, both of the graphite electrodes, and here this is an cathode and this is an anode, and they are dipped in copper sulfate solution. They are dipped in copper sulfate aqueous solution. Now what happens? I have the copper sulfate aqueous solution will be having copper ions, sulfate ions. It will be having 8 positive ions and OH ions. Now, according to the rule, this is a dilute solution, right? According to the rule, on the basis of the position in the electrochemical series, copper will be discharged because copper is below hydrogen. And similarly, OH will be discharged because OH is below sulfate. Now we know that the copper is discharged. So after discharging, the copper will go where? The copper will be going, because it's a cation, it will be going towards the cathode. This is a positive terminal, this is a negative terminal. So my copper will be going towards what? Batao, come on. This is a cation. So it will be going towards the cathode. And which is the cathode? This is my cathode. This is my cathode. So the copper ions will be going towards the cathode. That means the copper ions will be moving toward this side, and OH ions will be moving towards this side, right? So uh, the copper ions, when will be we always write down the anodic equation first. So when we write down the anodic equation, 4 OH ions will be losing 4 electrons to produce 2 water and to produce an oxygen. ठीक है? And the cathode equation क्या होगा कि यही 4 electrons will be grabbed by the copper ions, and these 4 electron on grabbing, so 2 copper ions will be grabbing 4 electrons, forming 2 copper. तो इसकी वजह से होगा क्या कि कॉपर जो होगा वो डिपॉजिट हो जाएगा एट द कैथोड लाइक दिस. Okay, and from here what will happen? The oxygen will be liberated. So this is happening when you have both the electrodes at as inert. ठीक है, both are inert electrodes. So this is the story, this is the scenario when the inert electrodes we are dealing with. But when we are dealing with the active electrodes, only difference is we have a copper anode dipped in copper solution. Now what is going to happen that instead of getting at the anode, this is an anode, so instead of getting OH ions going towards the anode, what will happen in the active scenario? Active scenario, the copper electrode itself will start discharging the ions. That means the copper will itself undergo the process and it will give the copper ions and will lose the electrons. And those electrons which is going to lose, they are left on the plate. And what will happen? The copper ions, they'll be jumping into the solution. और actual process में क्या है? Actual process में OH ion from the solution, they are moving toward the plate. They are actually losing 4 electrons per 4 hydroxide और वो यहाँ पर भी oxidation process ही हो रहा है. ठीक है, और यहाँ पर भी when the copper ions are jumping into the solution, after losing the electron, the oxidation is still taking place. But instead of having the OH ions, it is interfering in the process. It is interfering. It's not letting the OH ion to be discharged. Instead, what it's doing, it is itself being decomposing or decompose. Okay, वो कॉपर आयंस को वो डिकम्पोज होकर ये रिएक्शन प्रोड्यूस करता है और कॉपर आयंस जो है वो after decomposing, after losing electrons, it will be jumping as copper ions into the solution. Okay, is that clear? Now what is happening? The copper ions are already there in the solution. ठीक है, उसमें copper ions हैं, इसमें hydrogen ions हैं, इसमें OH ions हैं, इसमें sulfate ions हैं. Why? Because we have a dilute copper sulfate solution. So what is happening next? Now this is going to act as an inert. This is going to act as an inert. Now, when it is going to act as an inert, which ions? So copper ions will be, as usual, are going to deposit, they're going to the anode, and here what will happen? The copper ions will be grabbing the electrons and the copper metal will be formed. So as usual, because it's acting as anode, तो यहाँ पर कॉपर डिपॉजिट्स जो होंगे वो यहाँ पर इसको चारों तरफ से कैथोड को प्लेट करेंगे. तो बेसिकली क्या होगा, ये यहाँ पर इंटरफेयर करके हाइड्रोक्साइड आयंस को इसी में छोड़ देगा, अपने आप इलेक्ट्रोलाइज होने लगेगा. ठीक है, तो ये प्रोसेस जब होती है तो ये हमारा एक्टिव एनोड की प्रोसेस होती है. इस प्रोसेस की दो एप्लीकेशंस हैं. वन एप्लीकेशन इज योर इलेक्ट्रोप्लेटिंग and the another process is basically electro refining. So electroplating, so whenever we have to plate any object, let's suppose we have to plate any spoon silver with the silver, so that we are going to have at the cathode, right? Spoon we will have at the cathode and silver we will be having at the anode dipped in silver solution. So what will happen? The silver is going to coat the spoon here because it is going to act as a active electrode. तो यहाँ पर process क्या हो जाएगी? Electrolysis की वजह से आपकी electroplating हो जाएगी. ठीक है? Okay. So in this scenario, as I told you, when we have the active electrodes, we are dealing with the case of aqueous copper to sulfate using the copper एनोड. मैंने आपको बताया अभी कि अगर हमारे पास जिस मटेरियल का एनोड है, अगर वो अपने ही सॉल्ट सॉल्यूशन में डिप्ड है तो वो एक्टिव एनोड कहलाता है. ठीक है, एक्टिव एनोड का दो काम होते हैं. इट हैज टू फंक्शंस. नंबर वन, इट हैज टू कंडक्ट इलेक्ट्रिसिटी, एंड नंबर टू, it will be interfering with the process electricity, and it is going to interfere in the process. Interfere means it will not let what is actually supposed to be done during the process. In fact, it is ये अपनी मर्जी से ये behave कर रहा होगा. ठीक है, तो एक्टिव एनोड में होता है क्या है, अगर हमारे पास डाइल्यूट कॉपर सल्फेट का सोल्यूशन है, अगर मेरे पास इनर्ट इलेक्ट्रोड्स हैं, if I have inert electrodes, so what will happen, the OH is supposed to come towards the anode, and OH की वजह से यहाँ से ऑक्सीजन डिस्चार्ज होती. ठीक है, बट एक्चुअली ऐसा नहीं होता. व्हेन यू हैव एन एक्टिव एनोड, तो एनोड जो है वो क्या करता है, दैट सेल्फ डिकम्पोज और इट्स गोइंग टू डिसोसिएट इनटू द कॉपर आयंस, और उसके बाद इलेक्ट्रॉन्स, बिकॉज यहाँ पर प्रोसेस क्या होगा, कॉपर जो है it is going to give you copper ions and it is going to give you 2 electrons. So the electrons will be coming onto the plate और यहाँ पर process of oxidation ही होता है. वो electrons from the anode they will move towards the cathode. और cathode जो होता है वो inert ही act करता है. So when the cathode is inert, so the copper ions from the electrolyte will be going towards the cathode, and they will be accepting the two electrons, ठीक है, and they will be forming copper. So because of which what will happen, there will be a copper deposit all around the cathode. Okay, so the inert electrode, they'll behave as usual, they are not going to interfere, but the active electrode OH आयन को आने से स्टॉप कर दिया, और इंस्टेड ये प्रोसेस स्टॉप कर दिया. इंस्टेड उसने क्या किया, अपने आप को कॉपर आयंस की तरह में कन्वर्ट करके स्टार्ट जंपिंग इनटू द सॉल्यूशन. ठीक है, तो इट हैज इंटरफेयर्ड विद द प्रोसेस ऑफ इलेक्ट्रोलिसिस. तो अब यहाँ पर क्या हो रहा है, कॉपर आयंस की कॉन्सेंट्रेशन, विल इट इंक्रीज और इट विल डिक्रीज? द कॉपर आयंस आर ऑलरेडी इन द सॉल्यूशन. So there are certain copper ions, after losing the copper atoms, after losing electron, they'll be jumping into the electrolyte. But almost the same on the other side, the same copper ions will be moving toward the cathode to accept the electron, and they'll be deposited like here, right? So basically the concentration of the electrolyte it will remain unchanged. It will remain unchanged. Because the concentration of the electrolyte will remain unchanged, so what will happen? The color of the electrolyte will remain blue. Whereas when we were looking at the scenario of the copper sulfate with the inert electrodes, the copper ions from the electrolyte, they were depositing. Okay, so the copper ion concentration was decreasing. That's why the copper electrolyte's blue color was fading off. But here the copper ion concentration remains unchanged because the ions are jumping from the anode, and the same ions are going towards the cathode. So the concentration of the copper ions remain the same, जिसकी वजह से इसका ब्लू कलर जो होगा वो intact रहेगा, blue color fade off नहीं होगा. So this is one of the observation. The second observation will be that when the copper metal will be depositing at the cathode, so this is going to grow in size. When it is going to grow in size, so basically we can say that the cathode's mass is increasing. Whereas because anode, it's leaving as the copper ions into the solution, so the anode size will decrease. Its size is going to decrease, whereas the cathode size is going to increase. So these are the basic observation we'll be seeing when we'll be dealing with the active anodes, right? Now, this active anode is a scenario which has two application. The application number one, we have electroplating, and the second application is your electro-refining. Now, how it takes place in the case of electroplating? Electroplating may, supposing हमें nickel plating करनी है on any object, if you have to plate something with a nickel. So we are going to take the nickel at the anode, and as an electrolyte, we'll take the soluble solution of nickel, any salt. So here we have taken nickel sulfate, which is a soluble solution, okay, as an electrolyte, soluble salt solution as an electrolyte. And this nickel we are going to take it as at the electrode. ठीक है, तो और जो ऑब्जेक्ट हमें प्लेट करना है वो ऑब्जेक्ट हम लेंगे एट द कैथोड, right? Nickel is going to be my active anode. Now what will happen, nickel basically as a nickel ions will be coming into the electrolyte, और वही nickel ions जो हैं वो आपके कहाँ डिपॉजिट होंगे? On this object. They will be depositing on this object, ठीक है? और जब इस ऑब्जेक्ट को के ऊपर वो डिपॉजिट होंगे तो इस ऑब्जेक्ट के अराउंड उसकी प्लेटिंग हो जाएगी. सो दिस इज नोन एज इलेक्ट्रोप्लेटिंग, राइट? सो this is the nature, this is what the slide saying. The cathode, we will be keeping the article after cleaning it with the sandpaper, which need to be electroplated. At the anode, we have an active electrode, which is a pure nickel metal dipped in its own salt solution. So anodic equation kya hai? Anodic equation will be nickel basically is going to form the nickel ions, and it will be leaving the electrons on the plate. So here at the anode, again, the oxidation taking place. So these electrons from the anode, they will be moving toward the cathode. Cathode पे क्या हो रहा है? यही nickel ions जो हैं, they will be grabbing the electrons, and they'll be forming nickel, which will be deposited in the solid form. So this is at the cathode, reduction is taking place because two electrons are grabbed. At the anode, oxidation will take place because the electron has been lost. So this is basically the key, the prime what do you call it, mechanism behind the electroplating. Not for the very reactive metals, but we normally do the electroplating with the transition metals, which has certain impact on the appearance. Like, for example, copper we can plate with, we can plate with silver, we can do the plating with nickel or chromium. So these are the metals जो कि impact करते हैं appearance को, उनसे हम normally plate करते हैं, या zinc से, जो कि रस्टिंग, अगर आयरन को जिंक से हम प्लेट करेंगे तो इट इज नोन एज galvanizing, so it will prevent the iron from rusting. So these are not, we are not going to use them, the very reactive metals over there. No, this is not a reversible process. This is a one-way process. I hope I'm clear about the electroplating. Now let's see the second one. Now these are the equations which are going to take place. As I've already said, at the cathode, this is what will happen. The nickel, let's talk about the first at the anode, because anode is my active anode. So the reactions start from the anode. So anode, the nickel is going to lose electron to form nickel ions. We'll prefer to write down the loss of electron on this side with a positive charge. Say, so it is going to generate the cations, and these cations are going to get into the solution. And anode, because of this, the anode mass is going to decrease, right? Now there aren't any product being formed at the anode, but anode का जो mass होता है वो decrease हो रहा होता है. और nickel ions जब electrolyte में jump करते हैं तो same nickel ions will be accepting the electrons at the cathode, and the nickel will be deposited, and because of this the cathode mass is going to increase. ठीक है. और यहाँ पर वो जो कैथोड जो है वो उस ऑब्जेक्ट का बना हुआ है जिसके ऊपर वो प्लेटिंग होगी. सो द ऑब्जेक्ट विल बी प्लेटेड with the substance which is at the anode. तो जिस सब्सटेंस से आपको प्लेट करना है वो आपका एनोड बनेगा, और जिस सब्सटेंस को प्लेट करना है, which the object which need to be plated, it will be kept at the cathode. Okay, so this is the whole reaction behind it. Now observation will be the solution color, the electrolyte color will remain the same, but anode, because it is diminishing, it's reducing in size because the anode is jumping as an anion. So the size of anode will shrink and the size of the cathode will increase because the deposition is taking place. We move on to the next process here. This is again, they have shown how the silver plating of an object will take place. So when we have to do the silver plating of the object, so we are going to take the silver, we are going to take the spoon, the article to be plated at the cathode, and the material with which you have to plate that at the active anode. Let's say if you have to plate the spoon with the silver is taken as the anode. And then we are going to have a silver salt solution, okay, as the electrolyte. So here what will happen, the silver ions will be jumping into the electrolyte, and the same silver ions will be moving toward the cathode. They will grab the electron. This is what the cathode equation will be. Silver ions will be grabbing electron, forming silver, which will be deposited around the spoon. Okay. And at the anode, the silver will be dissolving, leaving the electrons on the plate, and it will be moving into the electrolyte as silver ions. Okay. And the electrons will be moving from anode towards the cathode. So there is no product formed at the anode, but the deposition of silver metal over the object will take place at the cathode. So this is how the electroplating is taking place. Coming to the electrorefining. Now, electrorefining is a process by which the metals, okay, they are being purified, the impurities are being removed, right? They have been purified and the impurities are being removed by the process of electrolysis. So refining means making pure, right? And by the process of electrolysis, that's why we call it electro refining. Now, here again, we will be using the active anode process. So in this scenario, this is what the electro refining is taking place. So whatever the ore we have, okay, ore have lot of impurities. So ore we basically dig out from the earth crust with lot of impurities, but they have the metal, the pure metal within it. Okay, it's kind of a mixture. So this is an ore of basically the copper. Okay, this is a copper ore. The example we have taken of copper. It will be taken as an anode. It will be taken as an anode. The ore or the impure copper anode we are going to make, and the cathode is going to be made up of pure copper. because we are doing the process of refining. So we have to have the impure copper ore at the anode. अब यहाँ पे क्या होगा, and the salt solution, the electrolyte is basically copper sulfate. Then only this is going to act as an active anode. So what will happen, because the electrolyte is copper sulfate, so the copper ions, they will be getting into the solution, and the copper ions, by what process? The copper ions, this is what the anodic equation is, कि copper जो होंगे, they'll be losing the electrons and they'll be jumping into the solution as copper ions. So the electrons which are left on the ore, on the plate, which is said to be, which is made up of ore, these electrons from an anode will be moving towards the cathode. और cathode पे क्या होगा, यही copper ions, they will be coming to grab the electrons from here, और ये ग्रैब करके दे बी डिपॉजिटिंग देमसेल्व्स अराउंड द प्योर कैथोड. ठीक है, ये यहाँ पर डिपॉजिट, ये ऑलरेडी प्योर कॉपर का है, तो इसी के ऊपर और मजीद डिपॉजिट होता जाएगा, तो वो बेसिकली प्योर कॉपर ही डिपॉजिट होगा. तो ये पूरा का पूरा cathode plus deposition will be pure, and the impurities will be falling below the ore as sludge. Okay, so this is how सारे जितना भी प्योर कॉपर होगा वो इस तरह से आकर यहाँ पर डिपॉजिट होता जाएगा और इम्प्योरिटीज गिरती जाएंगी. तो इस ओर में से हमने क्या किया, प्योर मेटल को निकाल लिया और इम्प्योरिटीज को अलग कर लिया बाय द प्रोसेस ऑफ इलेक्ट्रो refining, where I'll always keep my ore on the active anode. So this is basically my electro refining. All right.